A charged particle moving in a magnetic field will experience a force, and that force is given by the product of the charge with the cross product of the velocity of the particle and the magnetic flux density. So if the particle is not moving relative to the magnetic flux density, there is no force. And the force is going to be at a right angle to the direction of the velocity and the direction of the magnetic flux density. Now, this is not a derived equation. It describes experimental observation. And I am going to demonstrate this force now. Okay, I happen to have several of these thin disc magnets, so I put several of them in a stack. So this you can think of as just one larger magnet of this shape and size. And I'm going to attach this magnet to the head of this screw. The screw I will then attach to the battery, and I'm going to use a wire to attach the positive terminal of the battery to the side of the magnet here. And so what will happen is there will be a current. So there will be a current that flows out of the battery through the wire into the side of the magnet, to the center of the magnet, and then up through the screw and back into the battery. So a current flowing is a positive charge. So you can think of a positive charge as flowing from the edge of the magnet to the center. So this charge will experience a force because of the magnetic field inside the magnet, and that will result in a torque occurring on this magnet. This illustration should help clarify. So here we have our magnet, and so the magnetic fields come out the top of the magnet and come around and back in the bottom and through the magnet. Okay, now what we're going to do is we're attaching the screw to this top end here, and then I'm taking the wire and attaching it to the top of the battery and to the side of the magnet. So the current flow is going to be from the edge of the magnet to the center and then up through the screw. So the force on that current flow is just positive charge flowing from the edge of the magnet to the center. The force will be perpendicular to that direction and perpendicular to the direction of this magnetic field. So that will be a force that will act to rotate the magnet.